Auxiliary contacts, whether they're mounted on the front of the contactor or on the side of the contactor, it all operates the same. Most of the time they do run off a different voltage source or lower voltage compared to the main contactor voltage. For example, if you would run 480 three-phase on your line side of your main contactor, L1, 2, and 3, you might use your auxiliary contacts to bring in a lower voltage, let's say 24 volts DC, to run through your normally open or your normally closed contacts to control different loads, or as input signals. And usually if it's being used to control a load, it's usually a smaller load, like an indicator light. For example, if this contactor engages, you can run 24 volts DC through a set of normally open contacts that will turn on an indicator light, letting you know that the main contactor is on. You can troubleshoot it without power or with power. If you're going to troubleshoot it with power, just make sure that your main contactor coil engages. So as soon as A1 and A2 receives the proper coil voltage on the main contactor, it's going to pull in. You should then see this little black tab here engage or being sucked in, and then at that point you can then test it. If let's say you're running 24 volts through this set of normally open contacts, you should see 24 volts here and 24 volts on your output side. For your normally closed set of contacts, when the main contactor is not engaged, you will see 24 volts if you're running 24 volts through here. But once the main contactor engages, you will no longer see that 24 volts. You'll see it on your incoming terminal, but you won't see it on the outgoing terminal. So now I got to disengage from the main contactor, and we're going to check it without power. And without power, we're going to check it in the resistance setting. So right now I got my meters probed into a set of normally open contacts, and I pulled this tab here to close that set of contacts, and then you can see that we have a resistance reading of 0.3 ohms. That is really low. That is a good resistance reading. That means that the contacts have closed and we have a good path for current to flow. So you can see in the back of the auxiliary contacts, it's got these tabs here. And when it's mounted to the main contactor, it mounts onto here. When the main contactor engages and it pulls in like that, it also pulls these tabs with it. It pulls it out like that, which then closes your contacts. And if it's a side mount contact, when this pulls, it just pulls it in with it if it's mounted on the side. You can also check it in the continuity setting, but I've learned over time that sometimes the resistance is pretty high within the contacts, but continuity will still pick it up and give you a ringtone, even though it might have 20, 15, 30 ohms of resistance, which I believe are pretty high. I mean, when I'm ohming out a set of contact, I am looking for at least 1 ohms or less. So just a quick recap, your auxiliary contacts work when your main contactor is engaged. It runs in conjunction with the main contactor. This engages, it's going to either make or break your auxiliary contacts. Always pull off your auxiliary contact and observe these tabs too, because sometimes they do break, or the ones on the contactor, if it breaks, it won't engage. So until next time, deuces.